Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Alright, let me tell you a story. Imagine this, you wake up tomorrow and you remember nothing from yesterday, no lessons, no habits, no sense of who you are. That's not intelligence, that's amnesia. And that is exactly the problem many AI systems still have today. Now, here's where today's paper comes in. The paper is titled AI Meets Brain, a unified survey on memory systems from cognitive neuroscience to autonomous agents by Jiafeng, Liang, and Hao Li, along with their collaborators. And this paper asks a deceptively simple question: what if we stop treating memory in AI as a storage hack and started treating it like a brain function? Let's rewind. Humans don't just store memories. We encode, forget, update, replay, and reinterpret them. Your brain doesn't dump raw logs into a database. It compresses experience into meaning. But large language models, they're stateless. Every prompt is a reset. Every conversation is goldfish memory unless engineers duct tape something on the side. So means more context window or retrieval or embeddings, useful but incomplete. This paper argues something deeper. Memory isn't a component, it's a system. The authors walk us through memory from three perspectives. First, the human brain. Here, memory splits into short term and long term. Episodic memories, like what you did yesterday. Semantic memories, like knowing what gravity means. And the key idea, memory isn't static. Every time you recall something, you change it. That plasticity, that's intelligence. Then they move to LMMs. LLMs technically have three kinds of memory: parametric memory baked into weights, working memory, the context window, and external memory like RAG or vector databases. Each one solves a problem, and each one introduces a new limitation. Parameters are frozen, context is expensive. Retrieval adds noise and latency. So none of them alone behave like real memory. Finally, agents. This is where it gets interesting. In agents, memory becomes a cognitive loop. The agent experiences the world, extracts what matters, stores it in structured form, retrieves it later, reflects on success or failure, and updates its future behavior. That's not storage, that's learning. One of the paper's most useful ideas is how it classifies agent memory. Two axes. First, episodic versus semantic. Did this memory come from experience or from facts? Second, inside trial versus cross trial. Is this memory temporary for one task or persistent across the agent's entire life? This framework alone clears up a lot of confusion in current agent designs. Now let's talk implementation. Agents don't store memories like brains. They store them as textual graphs, vectors, or even weights. Text is easy. Graphs preserve relationships. Vectors compress experience. Weights make memory instant but risky. And here's a major pitfall: over compression. If you summarize too aggressively, your agent becomes confident but wrong. The paper shows that memory systems need forgetting, not just saving, just like humans. So, what's the practical takeaway? If you're building agents, don't ask, where do I store memory? Ask, how does memory evolve? A good tip from this work: separate experience logging from experience abstraction, log everything, but only promote high value patterns into long term memory. Let the rest fade. The paper closes with a glimpse of the future: multimodal memory, memory shared across agents, skills learned once, reused everywhere. A world where AI doesn't just respond, it remembers, it adapts, and it grows. And that raises a final question: if memory is the bridge between past and future, what kind of future will we teach our machines to remember? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.